2, Division Rules of Exponents, Part 2. If you didn't see Part 1, go check it out. It has some review of multiplication rules and the beginning of division rules lessons and explanations. So we had just talked about zero exponents. Anything to the 0 power is 1. And then something else that you might notice when we did the problems up above, when you have a to the mth power divided by a to the nth power, what you really are doing is a to the m minus nth power. Remember my little shortcut, opposite adding, subtracting, opposite of multiplying is dividing? And if it asks you to multiply them, you actually add the exponents. If it asks you to divide them, you actually subtract the exponents. So that's what we're going to use here. And here we go. So a few of our examples. X to the 5th power divided by x to the 2nd power. I'm going to expand it first so you can see why it works. X to the 5th power is the same as x times x times x times x times x, 5 of them. X squared is the same as x times x. And if we wanted to simplify it, we use the fact that anything divided by itself is equal to 1. 3 divided by 3, 1. Mrs. Adams divided by Mrs. Adams, 1. Here, x divided by x, that simplifies to 1. X divided by x, that simplifies to 1. And that's all that can be simplified there. So you end up with 1 times 1 times x times x times x, which we end up getting is x to the 3rd power. Notice if we had done the shortcut, it would have been x to the 5 minus 2nd power. And 5 minus 2 is 3. So there it is. Turns out this one, kind of weird, and I'll show you, is x to the 3rd power divided by x to the 4th power. We write it out, x times x times x. That's what we have in the numerator. Denominator is x times x times x times x. We're going to use that fun fancy fact, anything divided by itself is 1. That's equal to 1. That's equal to 1. That's equal to 1. What you'll notice is in the numerator, we're left with 1 times 1 times 1. That's our 1. In the denominator, we're left with an x. The answer is 1x, or 1 over x. Wow, 1 over x. And another way to look at that is if we use the formula we had, we'd have x to the 3 minus 4th power. And when we do that, we get x to the negative 1st power. However, you cannot have negative exponents as a final answer. You always have to change it to its positive. So the way to do that is to take and change its position in a fraction. If this were a fraction over 1, in order to make the exponent positive, you change its location to the denominator. So moving it down would give you x to the 1st power. All right, I'm going to let that sink in. It's kind of a weird one, but we'll continue to practice and look at it. Let's look at it with the next one. I come to this lovely thing, 6a squared, b to the 5th power, c to the 8th power, divided by 2a, b to the 3rd power, c to the 10th power. All right, we can write all of these out. Ooh, you ready for it? 6 times a times a times b times b times b times b times b. There's 5 of those. Oh boy. And c to the 8th power. Here we go. 1, 2, 3, 4, 5, 6, 7, 8. Wow. Okay. And then the next one, 2. Let's see, 2. That a doesn't have an exponent. Oh, wait. It does. It's a 1. So I just write it one time. Times b to the 3rd power. B times b times b times, and then we have c to the 10th power. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh. All right. Remember, numbers act as they always have. Nothing is new with numbers. If I asked you what's 6 divided by 2, the answer is still 3. And it could be 3 over 1. Let's see what happens as we go through this. The a's, a divided by a is 1, leaving me with just this a here. For the b's, b divided by b is 1, b divided by b is 1, b divided by b is 1, and we're left with b times b still here. So that's going to be b squared. And then for the c's, here we go. I'm going to cancel out the things equal to 1. Notice we're left with 2 of the c's left, c times c, and they're in the denominator. So that's where they remain. Notice that's a positive exponent down there. If we had used the shortcut, it would have been, whoo, it's getting messy. It would have been 6, a to the 2 minus first power, b to the 5 minus third power, and c to the 8 minus 10th power, leaving you with 3, a to the first power, which we don't have to write, b squared, c to the negative second power. So this right here is the same answer as this one right here. Except, remember, we don't want negative exponents in our answer, in our final answer. So in order to make it positive, we move it to the denominator, and we get c squared down in the denominator. So this is the technically correct answer when you're finally finished. Power of a quotient. So now that we have this, we do the same thing. This is kind of like distributive property again. If there's multiple things inside the parentheses, all of them get taken to the nth power. So a to the nth power divided by b to the nth power would be what you get there. And this final example here, 4/5 divided, or to the second power, would be the same thing as 4/5 times 4/5, which is 16/25. Or you could have said 4 to the first power squared would be 4 to the second power. And then 5 to the first power squared would be 5 squared. And then if you square those, 4 squared is 16, 5 squared, 25. Same answer, same problem. There you go. All right, this is the end of division rules of exponents. Woo, this is a long video. So we move on to the negative exponent rule, and this is it. Negative exponents, a to the negative nth power is the same thing as 1 over a to the nth power. And so here's our rule. Negative exponents. To change the sign of an exponent, use the reciprocal. That is, move the base and the exponent to the opposite side of the fraction, top to bottom, bottom to top, while changing from positive to negative for the exponent. And negative exponents are not allowed as a final answer. Unless they ask you to, you always have to have positive exponents in your answer, which means you might be moving where some of your bases and exponents are in your answer from numerator to denominator or opposite. So a few examples of those. If we have x squared y to the negative fourth power, z to the third power, and they say, what would this be simplified? And it turns out that x squared, that's fine. That's as simplified as it can be. Y to the negative fourth power, we can't have negative exponents. So I'm going to move it down here, and all that does is change its sign. So it becomes a positive fourth power instead of a negative. And then I look at z to the third power, z cubed. It's fine. I'm going to leave it back where it was. And that's it. All right, next one. We have negative 10 a squared b cubed c to the 8th power divided by 2a b to the 5th power c to the 9th power. Numbers. Numbers are the same as numbers have always been. There's nothing wrong with negative numbers. We like negative numbers. They can be in our answer. We're just talking about negative exponents not being there. So if I look at this first part, negative 10 divided by 2, that is negative 5. That has not changed. But when we go to solve the rest of them, if I solve a, here's 2, and on the bottom, the exponent here is 1, so it's going to be a to the 2 minus 1 power. For b, here's a 3, here's a 5, it's going to be 3 minus 5, or 5th power. And then for our c's, it's going to be 8 minus 9, always the top one minus the bottom, so 8 minus 9. In simplifying that, we end up with negative 5a, b to the negative 2nd power, c to the negative 1st power. Eek! That's not the answer we want. We cannot have negative exponents, so somehow we're going to have to fix these two right here. So that's going to leave us with negative 5a. Those were fine. We're okay with negative numbers. They're okay. Don't change them. But b to the negative second power, not okay. We can't have negative exponents, so we move it to the bottom to make it a positive squared. Same thing with c to the negative first power. Move it to the bottom, becomes c to the positive first power. Again, we don't have to write the 1. So we can have a little fun with this here. Can you rewrite the expression like this with only positive exponents? All right, I'm going to start moving some stuff around. You'll see that we can kind of do whatever we want, just changes the sign of the exponent. They're all positive. Let's see. Well, if I wanted to do that, a to the first power, a to the negative fourth power, if I actually solved that, that would be a to the 1 minus negative fourth power, which is really 1 plus 4. So a to the fifth power. For my b's, b to the third power, b to the first power. If I subtract that, 3 minus 1 is 2, b squared. And then for here, c to the negative second power divided by c to the seventh power. If I just do them like I normally do, it would be c negative 2 minus 7, which is the same as c to the negative ninth power. But we talked about only positive exponents, so guess what? I'm going to move that down here and make it c to the positive ninth power. And there it is with only positive exponents. Could we have written it with all negative exponents? I sure could. I could move the c to the ninth power up, making it c to the negative ninth power, over. I could move a to the negative fifth power to the denominator, making it a negative fifth power. A to the fifth power, making it a negative a to the fifth power. B squared, move it to the denominator, becomes b to the negative second power. Here'd be my answer if it was only all negative exponents. Can I move it so all of our bases are only in the numerator? Well, we sure could. That would give us a to the fifth power, b to the second power, and then remember the c, if we move it to the numerator, becomes c to the negative ninth power. Look, everything's in the numerator. Well, what if I want everything in the denominator? Well, I can do that too. Let's move all these down. A to the negative fifth power, b to the negative second power, c to the positive ninth power. It changes its sign. So kind of move these around, have some fun with them. Only do this, though, if the question asks for it. Hopefully this video is not too long or too confusing. Maybe watch it a couple times. All right, I'll see you guys later. Bye.